Hey, welcome back. This is a new app and this is one of my most favorite apps for this course. So in this video I want to demonstrate you what the app looks like and what it does, so you know what you're going to build throughout the next videos. So one of the things you have learned so far is how to build web apps with Streamlit, and you have also learned how to do data visualization inside Jupyter. Now for this app, you're going to join these two skills together and build a so-called data web app or data app. So this here is a data app, and it's called a data app because it shows visualizations, as you'll see in just a bit. So let me demonstrate you what this app is about. So that's the page where the user accesses the app, and the user can type in a place here. It can be any town, any city on Earth. Let's try something like Tirana. The user can press enter, and what you get is the graph with the temperature in the next 1 day. But the user can slide this and can have the temperature graph for 2 days up to 5 days. So you can see that in October the 1st the temperature will be at this point, and then it goes up during the day, goes down October 12th, October the 2nd, that's around midnight, and then goes up and so down. So that's for the next 5 days. We have the date and the temperature in degrees Celsius. But the user can also see the sky. So if they press the sky in the drop-down menu here, they should see the sky condition every 3 hours for multiple days. So that's for 5 days, right? You can slide the slider and everything is interactive. So you can see that the sky condition is updated to show only the next 3 days. So there we go. If you change back to temperature, it updates to show the temperature for the next 2 days, as you see the slider here. So that's the app. It's quite simple, but it is very interactive, and it brings together the power of Python and Streamlit. So we're going to use Streamlit to build this app. And as you can see, Streamlit can be combined with plotting, so the plotting can interact with widgets. That means you can build many kinds of apps using these interactions, these widgets, these elements that Streamlit gives you. So without further ado, I hope this is clear, and let's start building the app in the next videos. See you there. Hey, welcome back. In this video we will start coding the app which I showed you in the previous video. So where do we start? Well, as you might remember, we have had two kinds of apps during the course. We had apps without a user interface, such as a PDF generation apps where you just run the script and you get the PDF output. And then we had apps which did have a user interface. For example, the desktop GUIs, the to-do app, web or desktop version. So that had a graphical user interface. So this app will also have a graphical user interface, as you already saw in the previous video. So that's a web interface, but it's still a user interface. So where I'm trying to get to? Well, with apps which didn't have a user interface, the coding process was more linear. So we started from the input data in here, and then we coded until we produce the output data. Now, with apps which have a user interface, what we do first is we create the user interface first. We code the user interface first. And then we code the rest of the app, so the backend which gets the input data and it gives those input data to the user interface. So this is, again, what we're going to use in this app. That's the coding process. So in this video, we will start to code the user interface. Now, normally we would use a program such as Figma to code a prototype first, to make a sketch of how the user interface looks like. But since I've showed you already how the app looks like, then it's not necessary to go through Figma. So we already have the prototype, how it looks like. So that's a screenshot I made, and you can refer to this when you code the interface in Python. Of course, if you like to make a prototype in Figma, feel free to do that and then come to this video and then start coding. So you can find this image in the lecture resources, so you can get it and you can place it here in your project directory. So what I've done here is I created a new PyCharm project already, and I have this virtual environment, and I uploaded this image that you see here. And then we're ready to code. So let's create a main.py file and import Streamlit SST. And I'm going to place this image to the right side. So that's normally what you do. You have the sketch here, the prototype, whatever it is. It could be a simple sketch, it could be a more real-life prototype, which looks exactly like the app you want to build. It doesn't matter. So it's good to have it on the side. And so let's install Streamlit. And first we want to code the initial state of the app, which is without this plot. So that means we have this title, this text box here, this slider, and this drop-down list, also known as a select box. And then we also have this label here. So let's code those. With st.title, we create the weather forecast for the next days. So that's going to be the title, and the place is going to be st.text input place and a colon. So why did I place a variable in here but I didn't use a variable in here? Well, that's because this is a text input box which corresponds with this here, with this widget, and that's the title. The title is just a static element, so you don't need to get its value in a variable because you're not going to use the title in the script, but the value that the user will enter in this text box is going to be used further down in the script. So we need to capture that value in a variable, and that variable is place. So interactive widgets should have variables normally. The days, so the user is going to provide the place, the days, through a slider, which is going to have the title forecast days. So that title here. The slider is going to have a minimum value of 1 and a maximum value of 5. Why 1 and 5? Well, because we're going to get forecast data from a weather API. And that weather API gives us data for the next 5 days. So if the date today is 20th of October, we're going to have data until the 25th of October. So that's the part of the backend, how to get the data. For now, let's focus on the front end. Let's also provide a help icon. Perhaps you can see this here. So when the user hovers the mouse on top of this icon, they can see more information about this particular widget. So you can use help if you like. You can provide a description of this widget. Select the number of days or forecasted days. So we're telling the user what they can do here with this slider. And we also have the option, so what do they want to choose? Temperature or the sky conditions. So that will be the label of this select box widget, and then the options which should come as a tuple. So temperature, which is currently selected in this screenshot here, and we also have sky. So these come as strings, both of them. Right, I'll split this here because it got too long. And lastly, we have this subheader here. So that's a title with big font, and that's a subheader. So st.subheader. Now, this is going to be dynamic actually. So when the user enters a place here, that place is going to be injected into this title. Same goes for forecast days. So the number here, 2 currently, is going to also be injected into this string, and same goes for the choice, the option temperature or sky. That means this is going to be an F string. So the first is either temperature or sky, so that's the option variable, right? Whatever the user selects here. So temperature space for the next, here we have the slider, sorry, that's days, that's a variable that represents the slider, and then we have the string days, so the variable days, the string days, two different things in place inside a placeholder. Yep, let's give this a try now. So go to the terminal and do streamlit. Make sure that you are in a virtual environment, otherwise you may need to close this and start it again. Make sure this is venv here. So streamlit run main.py. That's the name of my file. And the browser will open, and that's what we've got so far. So we have the title, the text input box, the slider, and the select box, and this label here. So let's try something, a place such as Faro, press enter, and this was updated. So Faro was added to that subheader, and if we change the slider, this is updated to 2, change it to 3, it's updated to 3, and so on. Let's try the select box, try sky, so sky is also updated. So everything is working dynamically, and that's also the helper. So when you place the cursor there, it shows this pop-up about this slider. So it's working great. And that was the first step towards building the graphical user interface. Now, in the next video, I will introduce you to how to plot graphs on a Streamlit web app. For this video, that was it. So let's commit the changes. I'm going to enable version control with git, and then go to this button, commit. So that is day 32. Add widgets. That's what we did basically. So press on commit. You need to select what files you want to commit. So go to this folder. You want to add main.py to the git repository. Add, and let's create a .gitignore file. Add that to the repository as well. And .idea and venv, so these folders will be ignored. Also the app design.png file. But rename this file. It's better to rename it to not contain spaces. So like that, app design.png, and then provide that name in here, app underscore design.png. Then we're ready to commit. So we're committing .gitignore and main.py with that commit message, and press on commit. With that, I'll see you in the next video with some more code. Thanks. Hey, welcome back. In the previous video, we built this web app. Now we're going to add a graph here in this area. So let's go back to our code and add that graph down here. So as you know, Streamlit works on a widget basis. You see st subheader, st select box, and they are added one under the other. So that order, the order of your code, defines the order of the widgets in the app. Now, if we add a graph here, that graph will also be added under this subheader. To add a graph, you can use st.plotly.chart. So that's a method responsible to create a graph, and this method now gets a figure object as input. What is a figure object? A figure object, you can get it from a plotting library, from a data visualization library, such as Plotly or Bokeh. So both are good libraries, but we will use Plotly. Plotly tends to be a bit better and it's more popular than Bokeh. So Plotly is a data visualization library. That means we need to import it in here. So use import plotly.express as px. So that's the library. Basically, we import the module express of Plotly and we rename it to px. So just like we do with Streamlit st, we do this px here. So Plotly should be installed. Install Plotly. You can do it with pip also or with this section here, Python packages. Once you do that, then before you use the Plotly chart method of Streamlit, which expects a Plotly figure, we create a Plotly figure first. So we need to store it in a variable and then say px.line. So we're creating a line graph here. As you can see, this is a line graph. If you go to the Python console, you can check what other options you have. So you can import Plotly in here as px, and then you can do dir px, and you'll see that you have area, you have bar charts, bar polar. So for different scenarios, you have different kinds of graphs. Histogram, and that's the line plot we're using here. So you can explore them on your own, but usually you'll know what you need when you have a project at hand. And so you can do some research on Google what plot you can use for that particular project, and you'll find that out. There's a lot of content on the internet about Plotly. The line method expects an x, a y, and a labels argument. So x is the array of the data you'll plot along the x-axis, the values along the x-axis. So in our case, that would be the dates, right? We plot the dates along this axis, and then each date corresponds to one temperature. So in the y-axis, we will have the temperature values. So x and y should be array types of objects. By array types of objects, I mean things like a list object, or it could be a tuple, or it could be a data frame column, or a series, in other words. So anything that looks like an array of data, of objects, of values, of integers, whatever you call it, that could be provided as a value here. So that means let's create a date list. Later on, we're going to get these data from the weather API, but for now, let's create some fake data. For example, 2022, 25th of October, 2022, 26th of October, and a third one, 2022, 27th of October. So that's the date, and then in X you provide the date, right? Same we will do for Y. Let's create a temperature list. The condition here is that this list should have the same amount of items as this list. So these two should have the same length, in other words. So temperatures, let's say 10, 11, and 15. So Y will be equal to temperatures. And then lastly, we have the labels object. This is expected to be a dictionary. It looks like this. So basically what I'm doing here is I'm telling Plotly that in the x-axis, Plotly should place the label date, and in the y-axis, Plotly should place the label temperature in in degrees Celsius units. So that's the label inside quotes, and that's the label also inside the quotes for x and for y respectively. And that's the figure object. So provide that inside Plotly chart and then run the script. So if it's running already, that's fine. Just visit it. And there we go. That's the plot that we generated. So that's the first date, 25th of October, and the temperature was 10. And if you place your cursor over that point, that data point, you're going to get this pop-up window. And this tells you the exact values for the date and the temperature. And then temperature went from 10 to 11, and then it went up to 15 on the 27th of October. So that's a nice graph. But the graph is static now. So whatever we change here, the graph is not connected to these changes. To connect a graph to a change of a widget, for example, this slider here, is very simple to do. For example, I'm going to update this list using a list comprehension. I'm going to say days times I for I in temperatures. So that will update temperatures depending on the value of days. So basically what I'm doing here is this. We have this temperatures list. We have days. Let's say days is currently 3. So the user has placed the slider at the position 3. And then what we do here is that, and that will update the temperatures list. So you see now it's this. And these values now should be plotted in that plot. Normally, we will get the data, the actual data from the API. So we're going to have a function here, and the function will get days as input, and it will return the temperatures for that number of days, right? And then those temperatures will be placed in here. So that's the final code for now. And let's go to the browser, refresh. Let's change the forecast days to something else. So as I change that to 3, you see now the temperature is 30 here. Instead of 3, it's 10 times 3, right? If I go to 4, it goes to 40, and so do the other temperature values. So that's a dynamic plot there. Now, it's also possible to have a function here. Let's say def get data. This gets days as input. So days is that value. And then the function is going to get the data from somewhere using the request library and so on. But for now, let's pretend that the function got these data, right? The dates and the temperatures. So I'm placing these two inside the function. And then the function is giving us the temperature values depending on the days. It got those from the requests that it makes to the API, and you got temperatures here. So then the function will return something like dates and temperatures. So let me place it here just to demonstrate you what we've got. So that's a function, right? So if you call the function with a value of 3, this is what you get. So that's a tuple with two lists. The first list is the temperatures list, the dates list, this one, and the second list is the temperatures list, this one, which has been manipulated in here. It has been changed to this values, 30, 33, 45. And you can also do this. You can say dt is equal to that, and each of these variables, d will be equal to the dates and t will be equal to the temperatures. So basically you are deconstructing this tuple by extracting each list, the first list and the second list. That means we can do the same thing in here. You could say dt is equal to get data days, and then here you say x is equal to d and y is equal to t, right? So what will happen now is that when we run the script, Python executes the code, and then when the user changes the slider, Python executes the code again from top to bottom. So anytime the user changes the slider, the code is executed. And so if the user set 2 as the value at the slider, days will be equal to 2, right? And then when the function is called here, this value will be equal to 2. So that value basically goes from here to here, and then from here to here, and then from here to here. And then these two values are returned and they are stored in here, and then they are rendered in the plot. So let's see how it goes now. Refresh and change this to something else. And as you can see, the values are still changing, so depending on the value of the forecast. And that's how you plot data dynamically in Streamlit. This function can of course be in another script, and you can import it from here, as we have done several times during the course. So it's up to you what you do now with this code. But what we will do later on is we're going to get actual data from the weather forecast API. So currently we simply have some fake data in here. So with that, I can commit the changes, plot fake data dynamically, and commit. Thanks a lot. I'll see you later. Hi, welcome to today's exercise. For this exercise, you need to build a data app. The data for the app, you can find them in the lecture resources, so please download the CSV file from there. And if you open it in a spreadsheet program, it should look something like this. So let me zoom in a little bit, and we have several columns. The country column here, and that's the happiness index of each country. So the higher the value, the more happy the people of that country are. And then we have the GDP per capita, and then we have the index of social support, life expectancy, that's also an index. Then we have the freedom to make life choices, generosity, and corruption. For corruption, the lower the value, the more corruption there is in that particular country. So these are the data. Now, what you have to build is this app. So this will be an app where the users can plot different variables against each other. For example, currently by default, when the app loads, GDP by GDP is plotted And so that's basically the same column. That's this column. Therefore, we get this scatter plot. But the user can choose to plot, for example, GDP along the x-axis and happiness along the y-axis. Once they choose happiness in this select box, so both these are select boxes, then this plot is generated. So in each select box, you can place 3 different values. You can place more if you like, but 3 is fine. So if they choose generosity, then you've got this. So GDP along the x-axis and generosity indicator along the y-axis. And that's all we have. So that's a title widget, a select box, a title here, which also changes dynamically when we change these selections, so GDP and happiness. And then we have the plot here. And now let me give you some hints. If you don't want to get these hints, you can pause the video now and try to solve this app on your own. If you have troubles, then please come back to this minute of the video and play the video and listen to what I'll say now. So these are my hints. Number 1 is you can use the match case block. You remember we have covered match case in the basic sections of the course, and perhaps you will need 2 match case blocks, not just 1, because we have 2 select boxes. That was the first hint. The second hint is about the plot here. So you learned already how to make a line plot. This here obviously is not a line plot, so perhaps you can try to find the correct plot using dir px, as I showed you in the previous videos. If you don't find it, then the correct plot is a scatter plot. That was the second hint. And the third hint is that you can use a data frame and you can serve the columns of the data frame for the axis here. So these are some hints, some general ideas, some help. This is a tough exercise, so please keep that in mind, and it's very likely that you'll not be able to complete it 100%, which is completely fine. So with that, thanks a lot, see you later. Hi, in this video I'll show you my solution to the data app. So I demonstrated you how the data app should look like, so that's the data app, and here is my code. So in this PyCharm project I have 2 files, happy.csv and main.py. So this is main.py, and that's what I have. So I imported Streamlit, Plotly and Pandas. I added a title to the web page. Then I added 2 select boxes, which correspond to these 2 select boxes in here. So when the page loads for the first time, by default GDP is the selection of both select boxes. That's because GDP is the first item of the tuple here. So that's a tuple which contains the values of the select box, and that's the title of the select box which corresponds to that. Then I load the data frame, because now it's time to get some data from happy.csv. And that's my match case block. So I have 2 match case blocks actually. There we go, that's a complete code. So this is how I did it. I set here match option X. Now option X is this first select box, and option X will get as a value one of the selections. So either the GDP string, happiness string or generosity string. So wherever the user selects here in the first select box, that string is going to be the value of this variable. That's why here I'm trying to match the value of this variable against happiness, against GDP, against generosity. So in other words, I'm trying to guess if the user entered happiness. If they entered happiness here in the first select box, then I extract the column happiness from the data frame. Now, it is possible that you have done this a bit differently. Perhaps in here you have this code. So perhaps what you're doing is you're checking if the happiness is a value and then you render that directly. But I think this might be a bit better because it's less code. So it's better to prepare the variable first. So in this case, if the user entered happiness as a choice here, if they selected happiness, then I prepare the happiness column. Otherwise, I prepare a GDP column. The variable is the same, by the way, so X array will get one of these values. So that or that or that column. Same goes for the option Y. It's the same code, basically. Then we have the subheader. The subheader is a string which I'm constructing dynamically, so it corresponds to that. So you can see that the option X variable will be rendered here as happiness currently, because the user has selected happiness, and this will be rendered as GDP. So we generate a figure first, and the X is X array, so that's a data frame column. That means at this point here, we should have a value for X array. So the value should be either of these three, right? And that column is going to be used as the X axis. Same for Y array, and then we have the labels argument. So in the X axis, we will render the happiness string in this case, when the user enters happiness here, and for the Y-axis we will render GDP, so the selection that the user makes here. And then we plot the chart, and that's it. So that's the final code. Don't worry if you did this differently, or perhaps you missed something. It's important that you have thought about this problem, and that helps a lot. Simply coding some lines helps a lot. So thanks a lot for listening to this. I'll see you later.